Congratulations on your interest in the Montgomery County Science Day. I am Dr. Alan Lefkowitz, and for the next little while, I'm going to lead you through the basic information everyone needs to successfully complete a science fair project. Several years ago, I was where you are, and I had questions about science fair, but thankfully I had science teachers and family who helped me through this process. My experience with science fair was very positive, and it played a role in my going to college where I studied both chemistry and pharmacy. So while today you might not think of yourself as a future scientist, being involved with the Montgomery County Science Day might be a step in that direction or toward another fulfilling profession. Maybe you are wondering why you should participate. Well, this slide is meant to help dispel some of the myths that exist about science fair. Some look at science fairs and only see them as a requirement for a science grade. Some see it as just a bunch of work and too many decisions. This results in some people thinking they just can't do it, or if they try, they may fail. And some think only straight A students can do well. None of these objections convey the realities about science fair. Science fair projects encourage self-learning and exploration for the truth. With a little bit of planning and giving your best effort, completing a science fair project can be a source of pride and accomplishment. But beyond pride and the sense of accomplishment, sometimes your project can be the source of rewards and recognition. Sometimes there are prizes and money, but other times a good project can result in college scholarships or be a doorway to a summer job. A good project can also be a source of new skills, such as organizational skills, critical thinking skills, and public speaking skills. So who can participate in the Montgomery County Science Day? Starting in 2018-2019, anyone in grades 5 through 12 attending a public, private, or homeschool can participate. And while most will complete a project individually, a team project with one or two other students may also be an option. As it is the more common scenario, most of what I will discuss for the rest of our time will involve individual, not team projects. Another requirement is that you need to be a resident of Montgomery County, Ohio, although in special circumstances, someone from an adjacent school district with prior approval may attend the Montgomery County Fair. Also, in order to participate, everyone must complete various registration forms and pay the required fees. We will talk more about some of these forms later in this presentation, but all of them are available from the Montgomery County Science Day website where you found this presentation. So how do you come up with an idea for a project? In the end, it is all up to you, but the most successful projects are the ones where you have a personal connection. You should begin with a broad area of interest, for instance, botany, and then narrow down your focus as you research the topic. For example, you might explore the effects of different types of light on plant growth. When your topic is something you are personally interested in, you will find this process more rewarding. In the end, you are most likely looking to answer a specific question. While different science fairs may have more categories, for the Montgomery County Science Fair, your project can fall into any of the 13 categories shown here on this slide. The 13 categories are behavioral and social sciences, biochemistry, botany, chemistry, computer science, earth and space sciences, engineering, environmental sciences, mathematics, medicine and health, microbiology, physics, and zoology. So what makes a good science fair project? This colorful slide is meant to provide you with the recipe for success. Each of the ingredients for a successful project listed on this slide will be discussed as we go through the rest of this presentation. This slide is meant to offer you a few websites with ideas about science fair project topics. Before I go on, you might want to pause this presentation and write some of them down to investigate later. As stated on the right, if you're having trouble narrowing down your list of potential projects, don't forget that your teachers and other professionals in the area of research may be able to help you. Finding a mentor in this process can make a world of difference in the success of your project, so it is strongly encouraged. And speaking of narrowing down your possible project ideas, this slide is meant to help you do just that. As you look at your list of possible ideas for a project, consider your own interests. Again, a project that you enjoy is more likely to be a successful project. Consider your current knowledge and what you might need to learn in order to do this project. Also think about who might be able to serve as a mentor for your project. This might be a teacher, someone in the field of science you're researching, or even your parents. You need to also think about what equipment is available to you for use. If you can't find the resources needed to do your project, a successful project isn't really possible. And sometimes, considering your own surroundings can help you limit your list of project ideas to make your final selection. This slide is just an example of how someone might work through a list of possible topics for a science fair project. Being honest about your interests, your knowledge and skills, and then who you might know or what resources you might have access to, including how much time you have, can help you find an achievable topic at which you can best succeed. So as this slide shows, and for an example that we will use as we go through other parts of this presentation, perhaps you are really athletic and you like sports, and maybe specifically you like basketball. So imagine you want to do a project involving how high basketballs bounce. And maybe you know Sue, who is an engineer, and perhaps you have access to a ruler or tape measure, as well as a pressure gauge. This might be the beginning of your science fair project. So keep this example project in mind, as we'll come back to it in a few slides. Moving on to the second step. Once the scope of your project topic has been narrowed, it's time to do some research. The first step of research is getting a good notebook where you can keep all of the information you find as you explore the topic. It is important to commit to documenting your work at all times. Using resources both online and in books, you need to obtain a sufficient amount of background information to begin answering some questions. Your research will help you to make an educated guess on what you think the answer to your question might be, and your research will help you to define what exactly you need to test. Your research will also help you to narrow the scope of your project in order to allow you to progress to the next step that we'll talk about, your research plan. While this research early on is so important, I don't want you to get the wrong idea. As you progress through your project, additional research will likely be necessary as you continue to pursue a thorough understanding of your topic. As I just mentioned, your next step is writing a research plan. And while it begins early in the process, in reality, it will gradually develop as you go through the entire project, as it will summarize everything you learned and did. Your research plan is generally a 3 to 5 page double-spaced document. In addition to having your name, your school name, and your grade, you need to also come up with a title. While this may change as the project continues, your title should be a statement of the problem you're trying to solve or the question you're trying to answer. This can be a brief statement, but it definitely should be less than 1 paragraph in length. The bulk of your research plan consists of your organized background research and will include the most pertinent facts and figures that you found during the previous step. This slide is meant to show you 3 of the most important parts of your research plan. First, you want to describe what your project is all about. You might call this the rationale behind your project, or what do you want to study and why. We will talk more about it in a few slides, but your research plan must also include your hypothesis. That is what you think the answer to your project question will be and why you think that. Another important part of your research plan is a bibliography of all the sources you use within your research. It is only proper to make sure that any quotes or facts or figures that you use within your project properly credit the sources that they come from. And this is also important to help you validate that your sources are reliable sources. Once your research plan is begun, but before you start your actual project, you also need to begin the necessary approval forms. Links to the forms you need should be available on the Montgomery County Science Day website where you found this presentation, but your topic will determine the types of forms that you need. For instance, if your project involves people or animals or potentially hazardous materials, you need to get approval from a scientific review committee. The Scientific Review Committee, or SRC, is a group of qualified individuals, including a biomedical scientist, an educator, and at least one other member, that is responsible for evaluation of student research, certifications, research plans, and exhibits for compliance with the rules, applicable laws, and regulations at each level of science fair competition. By getting preliminary approval from an SRC before you begin your experimentation, you may find out if there are potential special precautions that you need to take or problems that you need to address related to your project. And whether you need us early in your project process or at the end, let me point out that the Montgomery County Science Day SRC, of which I am a part of, is here to help review projects. And at the end of your project, when you submit your registration for the fair, your project will again go through an SRC review to see if there are still any issues that remain that need to be corrected for the fair. Based upon the feedback of either your initial SRC or the Montgomery County Science Day SRC, you can either proceed with your project or make the necessary adjustments and modifications to your project to comply with all requirements. At higher fairs, there are also SRCs that may further guide you on modifications that may be required for your project. This slide provides a suggested timeline for the first few steps of your project. Most schools tend to hold an orientation toward the end of September or the beginning of October. Then the bulk of October is spent with the students selecting a topic and beginning to gather their background information. Then by mid-November, the research plan should be written up and submitted to your teacher for review. Throughout this process, teachers and students should openly discuss the student's progress and try to find answers to any questions that arise during the process. But as stated at the bottom of this slide, you can avoid a lot of stress by starting your project early and not waiting until the final few weeks before the fair. Moving on from the research plan, let's go back to talking about your hypothesis. I mentioned earlier that your hypothesis is actually a part of your research plan, but this slide helps define it further. First, let me state that engineering design projects do not require a hypothesis, but otherwise, every science fair project has to have a hypothesis. Your hypothesis is a statement that rewords your question in a way that helps define your testing. Your hypothesis is basically what you expect to happen. It is meant to be a prediction of what you think will happen during your project and why you think that. And while it doesn't say it on the slide itself, let me reassure you that your hypothesis does not have to change if at the end of your project you find out that your best guess was wrong. It's okay, and in fact it's quite common that your research leads you to reject your original hypothesis. This is part of why the middle of the slide says that it's strongly recommended that you include your hypothesis on your board regardless of its quality. If you knew for sure what was going to happen before your project started, there wouldn't always be a very good reason for proceeding with the project. But here you're exploring science, so just make your best guess and then see what happens. So let's go back to our example science fair project involving basketballs and how they bounce at different air pressures. In this case, a possible hypothesis might be that you expect the basketball will bounce higher at higher air pressures. And as you think about your hypothesis, you should begin to visualize your graphs that will demonstrate your experiment's results. Think about what data you need to capture the answer to your question. So once you have a hypothesis, you need to develop the procedure you're going to follow to get the answer to your question. So in other words, this is where you design your experiment. Your experiment should be based on the best scientific principles and practices. So a good experiment tests the relationship between an independent variable and a dependent variable. An independent variable is something you can control, while a dependent variable is something you cannot control and is therefore the variable you're studying or measuring in your experiment. So as your independent variable changes, for example, the pressure of your basketball, the dependent variable, the height of the bounce, is what changes. Then any other variable you may identify either has to be eliminated or controlled throughout all your tests. So you want to repeat your test over and over again, but in the exact same way. So don't bounce the basketball one time on the wooden basketball court floor and the next time on cement. Another variable you should control is the height from which you drop the ball. If you drop it from different heights, you're going to get different bounce heights, so you have to keep it at the same height each and every time. So why is it important that you develop your procedure or experiment design? Because science is all about repeatability. You should provide details in such a fashion that if someone else took your procedure and followed it exactly the same way, they will get the same results that you did. So carefully outline each step in your experiment that you're going to follow the same way each and every time you repeat the experiment. Another part of your experiment design is a list of materials or equipment that you're going to use. So be specific. If someone uses a rubber basketball, but you used a leather basketball, the results aren't going to be the same. Another important part of your project design that cannot be overstated is safety. Some experiments require the use of safety gear, such as goggles or gloves or a vented area, or some specific type of supervision. Other experiments may involve chemicals that need to be safely handled throughout the experiment, or perhaps after the experiment is completed, the byproducts have to be safely disposed of. These are some of the considerations that you will have to outline for your SRC because your safety is so critically important. As you work on your experiment design, you need to think through how you're going to summarize your data. Think about how a line graph or a bar graph could summarize the differences or similarities between your different tests. But unlike most other experiments, I should point out that for engineering design projects, one of the differences is that your project will involve a prototype being designed more than it will be collection of data. Now you are almost ready to gather your data. Your control group is the normal result that you might compare to your data. So this is where you have to design your data sheet or collection form so that you can properly and thoroughly collect all of the information you need to properly come to a conclusion. Each of your variables and data points need to be included so that all of the necessary information to complete your project are collected. Knowing that a good experiment involves multiple trials, you need to design your data sheet so that you can collect data from each experiment the same way each and every time, or you need to have multiple copies of the data sheet for each different experiment. Again, you want to control other variables as much as you possibly can. So you want to be sure to document anything else that might impact your results, such as the air temperature. This slide is just a sample of a data collection form that you might possibly design for your basketball experiment. You will need multiple copies, one for each test that you run. But in addition to recording the date, time, and temperature, you're going to need to measure the ball pressure, the ball bounce, the drop height, and the rebound height. And then at the bottom, you can see an observation area where you can write those things that may happen that could potentially impact your results. Having a clear plan about your project is critical because the better you can plan, the simpler your testing will be. Having a control group or the normal, status quo scenario can help you see the difference produced by your experiment's interventions. This is why you want to document all of the conditions that might impact your experiment. Record everything in a timely and accurate fashion. Capture the details. This includes even your data that you think points to a failure. Regardless of whether you think your test passed or failed, record it. It's all important for the success of your project. Sometimes a science fair project is a student's first encounter with applying statistics. A part of analyzing your data is the use of graphs and statistics. There are a lot of different ways to do statistics, so that makes it difficult to go into here. But your analysis might be as simple as an average of your data with a standard deviation to something more complex like scatter plots, p-values, or regression analysis. You might use bar graphs, pie charts, two-way tables, or other ways to represent your data. Different projects require different statistical methods and testing. Another question that comes up often is how much data do you need? Running an experiment only once is never enough. Again, science is about repeatability. Depending upon your specific project, you might need to run it 3 times, or you might need to run it a dozen or more times. But in the end, you want to report all of your findings, especially anything interesting about your results. So again, we come back to our basketball project, and you can see 2 different ways to graph the data you might collect. On the left side, you can see how the graph is depicting the different heights from which the ball is dropped, and then with different ball pressures, the ratio of bounce to drop height increases. Then on the right side, you can see how the different ball pressures perform at different drop heights. Once you have collected and analyzed your data, you are ready to form your conclusions. As stated at the top, this is an overall summary of your experiment where you answer whether or not your hypothesis was correct or incorrect. As I said earlier, and as it says here on the left, if your hypothesis wasn't correct, that does not mean your experiment failed. But when something different than what you hypothesized happened, then you want to think about why that might have happened. And it's at this point, when you are almost at the finish line, that you want to consider what else you might have done differently, such as more tests or a different environment, or perhaps a different experiment altogether. With your experimentation all behind you, now you have to prepare to present it at the science fair. 2 important tips are shown on this slide. First, focus on the knowledge you've learned throughout this process and impress the judges. We'll talk more about the questions on the next slide, but anticipating what they might ask will help you prepare or to discover whether you might need to learn some more. Your presentation is something you're going to want to practice several times so that it becomes natural for you to clearly and quickly describe your project. The second tip is to think about your project board as a big note card. As you design your board, think about the key words or topics you need to be sure to discuss, and think about how you will explain the graphs of your data. With some preparation and practice, you can do this. Although you might be intimidated by what the judges might ask you, this slide presents some of the more common questions that you should be prepared to answer. Questions include where you got the idea for your project, what you wish you had done differently, or what you might do if you were to repeat this project for a second year. By thinking through your answers to these types of questions before the day of the fair, you are less likely to be nervous or flustered when you give your presentation, and you might even find an area of your topic that you need to dig into just a little bit more before the science fair. Another important consideration is the image you convey. Your appearance and your actions on the day of the fair are very important. You want to project the image of someone who may be the next budding engineer, scientist, or researcher. And of course, you want to dress for success. Dress like a professional. Also, as you present to the judges, be sure to show your excitement for your project and demonstrate what you were excited to learn about during the entire process. But something else to remember is that even the day of the fair, you have an opportunity to learn more about your topic. Many people overlook this, but just as the judges will ask you questions, you can also politely ask the judges questions. Perhaps you can learn from their expertise, but most importantly, you might get some tips on how you can do things differently and better in the future, or some ideas of how you might improve your project before the next fair. This can be particularly helpful if you do go on to district or the state science day. Another important consideration about your project is getting proper exposure. While there are rules and guidelines related to your project board, especially at higher levels of science fair, your project board should be creative and attention-grabbing. And if you want more attention and traffic, consider a project in an area that involves a current-day public concern, perhaps something related to water purification or genetically modified foods, or some other newsworthy topic that you want to become an individual expert on or an advocate for improvement. Beyond the Montgomery County Science Day, there are other opportunities to complete science projects. The first opportunity listed on this slide is the International Science and Engineering Fair, or ISIF. While the location of ISIF varies each year, it involves the best projects from students from more than 75 countries competing for more than $4 million worth of prizes, including scholarships, internships, scientific field trips, and laboratory equipment. One of the important things to realize is that the local Montgomery County Science Day is an ISIF affiliated fair, and as such, we select 3 projects as finalists and 2 projects as alternates each year. Other opportunities listed on this slide include the Junior Science and Humanities Symposium, the American Junior Academy of Science, the National Youth Science Camp, and the Gallery for America's Young Inventors. Each of these have their own rules and procedures, so be sure to check out their websites for additional information. And before I conclude, this slide contains not only the web address for the Montgomery County Science Day website and the Ohio Academy of Science website, but also the names of myself and some of the others who are willing to help you continue on your science fair journey. I hope this presentation has encouraged you to explore your curiosities related to science. I hope that doing a science fair project stirs up a drive to learn like it did for me several years ago. Let me thank you for taking the time to learn more about the Montgomery County Science Day. As this slide states, our future depends upon you, so let me wish you the best with your project and your future endeavors, and let me be the first to congratulate you on your upcoming success in testing possible solutions to a problem that means something to you.